Hello and welcome to lesson 14 of software design and development for higher computing science. Last time we did modulus. Today we're looking at the standard algorithms, algorithm specifications. Now, an algorithm in computing is just a series of instructions. So here is an algorithm. We've got an algorithm here. Well, this is the algorithm. These are the series of instructions. You may have heard of things like the YouTube algorithm. It's a bit of a misnomer. An algorithm is any set of instructions. For example, there's an algorithm to help you repair your punctured bicycle wheel or tire. And there's an algorithm for making a cup of tea. There's an algorithm for baking a cake. In programming, an algorithm is just a series of instructions. So what is a standard algorithm? Well, standard algorithms are called standard algorithms because they are algorithms that are used so commonly that they've just become standard. They've become standard algorithms because of how popular, common, and how commonplace they are. So these three are linear search, finding minimum and finding maximum, and counting occurrences. Finding min and finding max are almost identical, so we'll do those in one video. But this video today is about linear search. A linear search is when, let's say you've got a list of names and you want to find one of those names. You would, in a linear fashion, loop through an array and you would check each item in that array to see if it's the item you're looking for, if it's the target. And if it's there, you would return the location of it. If it's not there, you would display an error message or an apology saying, sorry, that name's not in the list. Now, here's a program that I already have, and all it's doing is creating a record structure to store each of these people. So we've got Olaf, Diana, Annie, Zoe, and Darius, and here are their scores in three very popular games, Candy Crush, Lemmings, and Donkey Kong. Very popular games. I've got one function called getData, and all it does is it loops through the file, creates a new player record for each person in the file, each line in the file, and it stores their data in that new record, appends that new record to an array, and it returns the array. To show you it working, I could get the first person in the player's array and display their name. Let's print that. This will print the first person's name, so it'll be Olaf. There we go, beautiful. And we can double check that, Olaf. So this just proves we have the data. We've got the data from the text file. Now, what I'm going to do now is create another function. Now, remember, at higher level, all of your programs must be modular. So you have to use functions. If you don't use functions, it's not a higher level program. It's a National 5 level program. So this one is going to be a linear search. I'm going to call it search name. And I'm going to search the players and I'm going to check their name for the target. So let's create a target. We're going to ask the user for it. Input, enter the name to search for. I'm going to close my files here. Enter the names to search for. Now, how you do this is you need to store a location of where that name was found. But you have to think, what if the name is never found? What if I search for Boris and there is no Boris? What's it going to tell me? Is it just going to crash? Or is it going to say, sorry, buddy, that name's not there? We need to consider this. So what we can do is create the found location and we need to say where it starts. Now, if I were to say it starts at 0, that implies that we've already found it in location 1. This would technically be the 0 person, Olaf. So we don't really want to do that. We want to start with a number that's not in the list. So -1 is where you would normally start. Then what you do is you would loop through every single player. So for player in players, so you could do it this way, but unfortunately doing it this way, you will not be keeping track of the index of the player. So we have to do it the old school way, where we say for I in range length of players. Now, some of you might be more familiar with this method anyway, which is great because this is the method we must use, because this is using the indexes. These are the locations in the player's array. So now what we need to do is just say if the target, is equal to the player at this index, if it's equal to their name. And if it is equal to their name, what do? We say found equals I. And you need to make sure you spell found correctly. And at the very end, we just return found. So this is returning where in the array we found that player's name. Now I could in my main program, say that I found it in the search name location when I give it all the players, and I could print the player was found at index and then add on where I found them. But let's say I do search for Boris. There is no Boris. So this is saying the player was found at index -1. Well, that's not true because the player wasn't found at all and there is no index -1. Although technically in Python you can say index -1, but that gets the last index. But that wouldn't be right because that's Darius. But in most other programming languages, -1 does not refer to any index at all. And in this case, we know that it's the wrong index. We know that that player was not found. So you would need to do a little if statement that would say if found does not equal -1, then you would say player was found at this location. Whoops. Otherwise, print that player is not in the list. Something like that. So now, if I search for Boris, that player is not in the list. But if I search for someone that is in the list, they're at index 2. Now, obviously, you would not show the user the index that they were found. You wouldn't show them that. You would show something else. You would maybe say, these are this player's high scores. So let's do that instead. So instead of just saying where we found them, let's print, here are the high scores for, and we can add on the players at location found, their name. Let's give us a bit more room. Bloop. And then we would print something like Candy Crush, and then join on their Candy Crush score. String players at found location dot Candy Crush. And we do the same for Lemmings and Donkey Kong. And this would be a much more realistic kind of output. Another thing is you should probably put this in a function, display output. And you would pass in the list of players and where you found them. And then this would be inside this function. In this case, it's a procedure because it returns no values. And you would just do display output, and you pass in all the players and where you found them. Now, the reason you put everything inside either a procedure or its own little function is because it cleans up your main program. Look at this. This is the main program. It's just 3 lines of code where we get all the data, storing it in an array called players. We find the location of a name that we type in, and then we display the output. So this is the entirety of the main program. Everything else is modular, it's inside its own little function, and if there are any errors, we know that it is limited to this function. But going back to the purpose of this exercise, it is the linear search. If I run this program, you'll see it is much more realistic now. Annie, here are her scores. She's quite terrible at computer games. A bit like me. Let's search for Boris. That player is not in the list. So we have a fully functional working program. And you can probably imagine ways that this could be used in the real world. So rather than it being a Python program, it might be a different program, maybe a computer game where the high scores are there and maybe you log into your account and then it finds your account based on your username and then shows you your own high scores, something along those lines. So the linear search, back to its foundations. You have to ask the user for a target. You store the found index initially at -1 because that is not in the array. Then you loop through the entire array, and if the target matches the item that you're looking at this point in the loop, we set the found variable equal to that index. What you do with that index later is up to you, but we decided to display all of their data because it was like a search. So there you have it. Linear search. It is the first of 4 standard algorithms at higher computing level. I hope you've enjoyed this one, and I'll see you in the next one.